Hello and welcome back to Code for Teachers. I'm Michael Taggart and this is episode 3, Conditionals, Input, and Numbers. So far we've discovered that information is classified in data types, and programming languages have to classify the kind of information we're working with so it knows whether or not it can perform a certain operation. We've already seen the string data type when we did our Hello World program. When we used the print command, we were passing strings to it. Now, thinking about what data type we're using is really important, not just in programming, but in life in general, classifying information into different categories. You can think about this like units in measurement, even in grammar when we're thinking about parts of speech. We always classify the kind of information that we're talking about, regardless of the domain of the knowledge that we're discussing. I think about it a lot like that toy from preschool where you have to put shapes into the certain shaped holes. You can think of the program as the box, and it has these interfaces for input, and you have to create input that matches the shape of that interface. So today we're going to learn how to control the flow of our program using conditional statements. What we saw before was that code runs from top to bottom, but we might not always want that to be the case, and we might want certain code to execute only under certain conditions. So inside conditionals, lines of code only get executed after a test is passed. And tests evaluate to true or false. We'll see a little bit more how this works in detail. But this is Boolean logic, so the study of when things are true and false. It sounds advanced, and admittedly I learned it in a formal logic class in college, but I discovered that I actually learned it first when I was learning how to search in my elementary school's library, how to combine terms using and or to make sure that I was getting exactly what I wanted. So the basic idea is like this: if P, then Q, and then if not P, then not Q, right? So we have a premise and then a consequence, and then if it isn't the case that the premise is true, then the consequence will not be true. It's a little bit easier to see using something called truth tables. And by the way, we call this Boolean logic because it's named after George Boole, the English mathematician and logician who created the formalized Boolean logic. So here's a very simple human sentence: if it's sunny, then I'll go to the beach. So if we were to create a Boolean truth table for this sentence, we would have two columns, sunny and beach. Sunny being the premise and beach being the consequence. So as you can see, if it is the case that it's sunny, if sunny is true, then we will go to the beach. That's true. But if sunny is false, then we won't go to the beach. We can extend this a little bit. We can add kind of a subordinate sentence to this, not a subordinate clause, but a subordinate sentence, where if it's sunny, then I'll go to the beach. Otherwise, I'll go to the movies. So now we have a separate condition. We'll have an action, a consequence, for when sunny is false. So here we have sunny, when sunny is true, beach is true, therefore movies is false because we went to the beach. But if sunny is false, then the beach is false, and because of that second sentence, otherwise I'll go to the movies, then that's true. Let's try to represent this in Python. So here I have my coding environment set up. We haven't done anything with it yet. So the first thing I'm going to do is I'm going to create a variable to store the state of the weather, if it's sunny or not. So I'm going to say sunny and then equals. And now we're going to use a new data type, that Boolean data type. And I'm going to set it to true, so that's capital T R U E. So now we have sunny equals true. And then I need to write my conditional statement. So I want to say that if it's sunny, I'm going to print out that I'm going to the beach. So if sunny double equals true, we'll talk about that double equals in just a second, print I'm going to the beach. Okay, let's try just that much. And let's make sure that the print statement is tabbed in inside of the if statement. And also, let's pay attention to this colon at the end of the if line. That's important. Python needs that colon to know that things tabbed in underneath of it are part of that conditional tree. Okay, so let's run this. And sure enough, we got I'm going to the beach printed out. Now, what's up with this double equal sign? What's going on there? Well, the single equal sign already has a meaning in Python. It means assigning a value to a variable. And so we can't use that for comparison tests. Instead, we use a double equal sign to compare two sides to see if they match. Now, this is an interesting case because tests in an if statement, and let's look at this syntax. We have the word if and then the test. And the test has to evaluate to either true or false. We have to write it in such a way that it means true or false. But because Sunny just is true, we actually have a shortcut that we can use to write this. We can just say if Sunny, and that will work exactly the same because Sunny already means true. So we'll run that, and sure enough, we get the same thing. Okay, so let's think about the movies then. How do we represent the movies? Well, if we do if Sunny print I'm going to the beach, we need a way to say I'm going to the movies otherwise. And instead of the word otherwise in Python and most programming languages, we use the word else. So I'm going to type else colon, and notice that it tabs in for me if I add that colon. Print I'm going to the movies. Okay, so if I change up Sunny to be false, then instead it's going to write I'm going to the movies. So I can determine which of these two lines gets executed by changing up the value of Sunny, and then this if statement and the else will control the flow of my program. Okay, so this was fun, but let's see if we can write a little bit more of a useful program. And to do that, we want to create an even and odd checker. And the even odd checker is going to do the following. It's going to check whether a user's number is even or odd. So how do we do that? What are the things that we need to figure out how to do in order to write that program? This isn't about the specifics of the code, it's just about the process. So I want to be able to ask a user for a number and then check whether that number is even or odd and then print out that result for the user. So what do we need to know how to do? We have to know how to get the input from the user, and then we have to determine whether a number is even or odd. And let's remember that concept is greater than code here. We want to spend more time thinking through the problem and articulating it in English than we do coding. So that's a really important step, and it's an important step in teaching it, that you spend your time on the idea, not just messing around in code. Sometimes code can help you clarify an idea, but the mark of a really logical and computational thinker is somebody who can articulate the problem without using code. And in that way, you guarantee that your program is going to be following a reasonable pattern. All right, so let's get started here. So I have this template, this even odd checker template, and you'll also notice that I have two different kinds of comments now. We've already seen this single line comment, this hashtag, get input from user here, but the top of our program, I've used multi-line comments, which are created by triple quotation marks, beginning and ending the multi-line comment, and Python programmers often use these as headers for their programs. And so it's saying that it's the even odd checker, and it takes input from user and determines whether that number is even or odd. So the first thing we need to do is get the input from the user. And we need to store it somewhere. So we're going to create a variable to store that information. Even though we don't know yet how to get the input from the user, we know we need to store that input. So let's make a new variable, we're used to doing that now, called test equals. And then what are we going to put on the other side of the equal sign? Well, it turns out that Python has a built-in method for getting input from the user from the console here on the right-hand side. So we're going to type input, and then just like print, it takes a string as extra information. What number should I test? And as you might be able to infer, what that's going to do is it's going to ask that question when I get the input. And let's just print test on that second line just to make sure that our code is working so far. So I'm going to run this. I get the question, what number should I test? And then if I type on the right-hand side, and I'll say 7, then it gives back 7. Now, some of you might be skipping ahead and thinking, you could have put a letter in and there's no way to prevent that from happening. That's true. We're not defending our program against bad input just now. We're focusing on how to do the process, expecting good input, and then we can add defensive programming later. All right, so that works, and I'm going to comment out that print test line just because I don't need it right now. So once I have the input, I need to do something with it. I need to check whether it's even or odd. How do we check whether something is even or odd? Well, as the definition goes, if it's divided by 2, it's divisible by 2. So how do we check if something is divisible by 2? We could divide it by 2 and then check to see if there's a remainder, but that might be weird depending on how Python does division. And in fact, let's find out how Python does division. So over on the right-hand side here, I'm going to, again, show you that we can do basic operations right over here. So 3 plus 5. Let's do 12 slash 2. That's 12 divided by 2. It gives me 6.0. And let's try 25 divided by 2. And that gives me 12.5. So, okay, I could check to see if if it ended in 0.5 or something like that. But it turns out that we have another built-in operator that's a little bit more useful, and that's the modulus. So let's play with that for a second. So if I do 10 modulus is the percent sign, 10 modulus 2, I get 0. If I do 10 modulus 3, I get 1. What's going on here is that the modulus returns the remainder of integer division. So 10 divided by 3 is, of course, 3 with a remainder 1. So I get a remainder 1. So this is really interesting because any number mod 2 is going to return 0 every single time. So I can use this as a pretty solid check whether a number is even or odd. So if I'm checking if mod 2 equals 0, I could say if test mod 2, and remember, the test has to evaluate to true or false, so equals 0. So this here is my test, this whole thing. If test mod 2 equals 0, so if the result of this operation equals 0, print, it's even. Else, print, it's odd. Okay, so let's make sure that we have all of our syntax right. We've got colons after our if statement and our else, that our two prints are tabbed in, and let's give this a run. What number should I test? So 7, and I'm expecting it to say it's odd. Oh no, I got an error. I knew this was going to happen and I wanted you to see it. So what's going on is a type error. Not all arguments converted during string formatting. Okay, so here's what's going on. When I use input to get input from the user, what data type do you think comes back? Well, it's text, and it could be arbitrary text. As I said, I could have written the letter A, and input would have taken it. So it turns out that input brings us back a string, which is not helpful when we're trying to do math on it. So what we need to do is we need to convert the input into an integer. I'm going to show you how to check the type of something using the console here. So we can actually use type and then 7. And that allows us to check the type. So 7 says that it's int. If I put quotes around it, it'll tell me that it's type string. And just one more, if I put 7.0 in front of it, that's a float. Decimal numbers are considered differently than integers. Right now we're only working with integers, but just know that ints, strings, and floats are 3 different kinds of data types that we have in Python. Okay, so if input returns a string, we need to turn it into an integer. Python has a built-in way to do that, and all we're going to do is write int and then wrap the input in extra parentheses. And what that's going to do is it's going to coerce the string into an integer if it can. So if we give it a 7 and it recognizes that as a number, it'll say, oh, cool, I can turn this into an integer. To show you what that looks like, let's do int and then quotes 7. So this is a string, right? But I'm wrapping it in this int, and let's see what this returns. It returns, without quotes, the number 7. Okay, so this should give me an integer. Let's try running this. What number should I test? 7? It's odd. All right, let's run it one more time, give it an even number, make sure it's working out. 12. It's even. Looks like we have a working even odd checker. So let's review. We discovered that information is classified in data types and that the kind of data type we're working with is crucial to our program. We can also control the flow of a program with conditional statements, if and else. There's another part of the conditional statement that we'll cover in a later episode, but if and else allow us to conditionally determine what code we want to run. The conditionals use Boolean tests that evaluate to true or false to determine their flow. We also learned that we can get string input from the user, but we might need to change the data type, and that the integer data type lets us work with integer numbers. So I want to do a little bit of housekeeping now on our third episode, and hopefully you're continuing your experimentation and your learning. And how do you keep learning between episodes? And how do you make this your own rather than just receiving information from these videos? So the first and most important thing is to play with it. Nothing surpasses experimentation for raw learning. Trial and error, constant repetition, these are the things that I really believe in for skill learning. And concepts will kind of be inductive from there. You will discover patterns as you keep practicing, and you'll come to some revelations about the art of programming and maybe about life in general through your practice. But definitely play with it. Try to extend what we've done, use the base code, and then try to add to it. Also, I would recommend using the documentation. Docs.python.org is a great resource. Docs.python.org is a great resource. So here we are at docs.python.org, and you'll notice that there's a tutorial link. And inside the tutorial, there's a lot of information, more than we're going to need. So if we go to section 3, using Python as a calculator, you'll see a lot of useful things there, numbers, and that gives you an overview of the kind of operations we can do with numbers and how to play with some of the basic commands inside the Python shell. But definitely use python.org or docs.python.org as a resource. Ask for help. Definitely get in contact with me, or you can use social media to seek help. Stack Overflow is a website that I don't recommend you using right now because I want you to kind of struggle with the basics before just getting answers. But I can tell you that most of the time when I'm writing programs, I have stackoverflow.com open. And lastly, believe in yourself. The beginning of learning programming is really, really demoralizing because you spend most of your time getting it wrong. and you stop once you get it right. So it seems like the majority of your time is spent in failure, and that can be really tough to deal with. But stick with it, grit your teeth, and persevere, because everybody goes through that process, and that's the only way that people learn how to do this. It's not magic, it's not some genetically predisposed skill. Everybody can do this, and the rewards are pretty significant. All right, that does it for this week. I also want to encourage you to like this video, subscribe to the channel if you are enjoying this content. You can also check out some of my writing on educational technology at theforeverstudent.com. You can check me out on Twitter at mttaggart. And I'm also on GitHub, and a lot of the code that I write for education and for helpful tools is going to be available at mttaggart on GitHub. All right, that's it for this time. Thank you for watching Code for Teachers.